Hello all, welcome to the video lecture series for the subject operating system. Now I am going to explain you all about the fifth algorithm, that is LOOK, disk scheduling algorithm. Let's check whether this algorithm gives the much better arm movement when we compare to the previous algorithm, right? So let me tell you what is this look algorithm is all about. It is actually similar to the previous algorithm, that is scan disk scheduling algorithm, except for the difference here. You can check it, that is, in spite of going to the end of the disk, let me tell you, in spite of going to the end of the disk, that is 199, it will stop exactly at the request with the highest number, right? So it goes only to the last request to the service in front of the head, and then it will reverse to the direction, and there exactly it stops at the last smallest request, right? Here it is right side, last highest request, and it will stop at last smallest request. When we compare this with the previous algorithm, the disk here, it is not completely scanned, it will be scanned only to the request. That means we have reduced, that is, this particular algorithm, look disk scheduling algorithm, reduced instead of moving to the last point of the disk, right? So the time is actually armed here. Now this is the question given, the same question, same head position, and the same request is given. So here it is clearly mentioned, it is the head, it is actually discom is moving towards larger value, right? It has been clearly given here. Let's check how it has been moved. Now the header is exactly here. It will point in the right side, which is the last point of this particular request. The last point, it checks 82, no it is not 82, 140, no it is not 140, 170, no, and 190. So here it starts from 50 and it will end exactly at 190. So what are all the requests we made here? That is 82 has been requested, and then we have 140, right? So we have 170 and we have 190, right? So slightly it is serving all the other requests which has been made. It is not stopping anywhere. It is making the request and it is serving the request and stops at 190. And it will check that this is what the larger value, it will always move towards the larger value. When we compare this 50, the larger value is not 43, it is 82, and it is moving towards 190. Now it is time to reverse the process, and it is reaching to the end point from 192. The least request which is made here, it is 16. You can check it. So the least request is 16. It is moved towards here. And by the way, whenever it is moving from 190 to 16, we have the request called 43, we have the request, another request 24, and finally we have 16. So let's check number 1, number 2, number 3, number 4, and here it is number 5, 6, and finally 7. These are all the positions where it has been served, not stopped. That's a point, right? So here we are going to check how exactly it points here. Now the positions of this particular thing, that is sequence of serving, it started at 50, it is not stopping anywhere here. I told you already, it is not stopping anywhere here, it is stopping exactly at 190. This is sequence number 1. Again it starts from 190 and it is not stopping anywhere. Actually it is serving, not stopping, so it stops exactly at 16. So this is sequence number 2. Based on this only, we can able to calculate this particular arm position, right? That is total distance covered by a disk arm. So let's check how this total position has been calculated. Here it is, disk arm position. So that is equal to the first sequence. You can check it here. I have clearly mentioned in the dotted lines. First sequence is 1550 to 190. So the highest number, that is 190 minus 50 plus. Finally, we have only 2 sequence. So that is the answer. So we have 190 here and it stops at 16. So 190 minus 16, right? So the final answer will be minus 16, 149, 16. Okay. So the final answer is 314. So you can calculate and check. So this is the final disk arm position and the average has been calculated, so that the total overhead movement here is calculated based on the total distance covered by a disc arm is calculated as 314. So you people who is watching this video can able to check that which particular DA, disc arm, that is total distance covered by a disc arm, is much shorter in the sense throughput has been increased. Which particular algorithm is with smallest throughput, that is the highest value in this particular consideration part. I hope you understand about what is this disk look positioning and how this disk positioning look algorithm works based on the disk scheduling procedures, right? I hope you understand this particular topic and I hope you enjoyed this video. Thank you.